Geometric centers. Geometric centers. One by one we will discuss. There are various geometric centers. The first one is centroid. 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 Before we discuss centroid, first we should discuss what is a median. What is a median? Suppose if I take a triangle ABC. I take a triangle ABC. Take the midpoint. D is the midpoint. So BD is equivalent to DC. From the midpoint, draw a line joining the opposite vertex. That is called the median. Median is nothing but the line joining from midpoint to opposite vertex. Line joining from midpoint to opposite vertex. Line joining from midpoint to opposite vertex is called median. Again I am repeating, ABC is a triangle, D is the midpoint. If D is the midpoint, BD is equivalent to DC. Line joining the midpoint to an opposite vertex is called median. Median divides the triangle. Median divides the triangle into two equal areas. Median divides the triangle into two equal areas. That means ABD area. Write down as it is, sir. ABD area is equivalent to ADC area. Median divides the triangle into two equal areas. Median divides the triangle into two equal areas. I hope it is clear. That's the second point. Next, take the midpoint of this E. Take the midpoint of AB as F. So, it is nothing but AE is equivalent to EC. AE is equivalent to EC and AF is equivalent to FB. Line joining the midpoint of an line joining the midpoint to an opposite vertex. Line joining the midpoint to an opposite vertex. So these three midpoints will meet at a point and the point is called center of gravity or centroid. G is nothing but the centroid. G is nothing but the centroid. Centroid is nothing but point of intersection of medians. If three medians intersect and the point is called centroid Right, first we will discuss the concepts, then we will discuss problem by problem. Right, no need to hurry up. First learn all the concepts. First learn all the important concepts. Centroids. To discuss centroid, we should know what is a median. Take a triangle ABC, take the midpoint of a side, midpoint is D, BD is equivalent to DC, AE is equivalent to EC, AF is equivalent to FB. Line joining the midpoint to an opposite vertex. Line joining the midpoint to an opposite vertex is called median. Line joining the midpoint to an opposite vertex is called median. Median divides the triangle into two equal areas. Next point. Centroid divides median. Centroid divides median. Centroid divides median in the ratio 2:1. Centroid divides median in the ratio 2:1. Centroid divides median in the ratio 2:1. Suppose if I got a triangle ABC and D is the midpoint to an opposite vertex. This is called G. Centroid divides median in the ratio 2:1. So AG is to GD is called as 2:1. AG is to GD is called as 2:1. Centroid divides median in the ratio 2:1. So AG is nothing but 2/3 of AD. 2/3 of AD. And GD is nothing but 1/3 of AD. AG is nothing but 2/3 of AD and GD is nothing but 1/3 of AD. Centroid divides median in the ratio 2:1. Another very important point. Centroid divides median in the ratio 2:1. AG is to GD is 2:1. So AG is 2/3 of AD and GD is 1/3 of AD. I hope it is clear. Next one. Next one. There are total 6 triangles are there. 1, 2, 3, 4, 5, 6. There are total 6 triangles are there. So all 6 triangles will have same area. All 6 triangles will have same area. All 6 triangles, write down in the same format as it is. All 6 triangles has the same area. All 6 triangles has got same area. So it is nothing but area of triangle BGD. Area of triangle BGD. It is nothing but 1/6 of area of triangle ABC. 1/6 of area of triangle ABC. All 6 triangles will have same area. All 6 triangles will have same area. Another very important point. How to determine the length of the, I hope these points are clear, right? What is a median? What is a median? What is a centroid? What is a centroid? And centroid divides median in the ratio 2:1. How to calculate AG or GD? By using 2:1. AG is 2/3 of AD and GD is 1/3 of AD. All 6 triangles will have the same area. So each smaller triangle is nothing but 1/6 of the total triangle. Each smaller triangle is nothing but 1/6 of this total triangle. This is something with respect to centroid. How can I calculate the length of the median? There is a famous theorem proposed by a famous mathematician, Apollonius theorem. Apollonius theorem. By using this theorem, you can find the length of the median. By using this theorem, you can find the length of the median. How to find the length of the median, we will see. Let us take a triangle ABC. Let us take a triangle ABC. D is the midpoint of the side. From D, a line is connected. AD is called the median. AD is called the median. AD is called the median. Now listen carefully. Start from A. What are the sides connecting A? AB square plus AC square. It is nothing but 2 into. What is the median from A? AD. Either you take BD or DC, both are same, because BD and DC both are same. One more time, suppose if I take another midpoint E, from midpoint join the opposite vertex. From B, what are the sides connecting B? AB square plus BC square. It is nothing but, what is the median from B? It is nothing but BE square. Either take AE or EC. It is AE square. Similarly, take one more median. Take the midpoint of AB, F. What are the sides connecting C? Which is nothing but AC square plus BC square, which is nothing but 2 into CF square. Either take AF or FB. So it is nothing but AF square. Very important conclusions when how to find out when the sides are given, how to find out the medians. Sides are given, how to find the median. Sides are given, how to find the median. Sides are given, how to find the median. Very important concepts. How to find the median when the sides are given. How to find the median when the sides are given. Again I am explaining. Take a vertex A. What are the sides connecting A? AB square plus AC square. What is the median towards A? AD square. Either take BD or take DC, both will be same. Either take BD or take DC, both will be same. Here there are two important conclusions. The first conclusion is perimeter of a triangle. Perimeter of any triangle. You take any triangle, perimeter of a triangle always lies between sum of the medians and 4/3 of sum of the medians. Please make a note. By using this, you can solve a very tough question very easily. SM is nothing but the sum of the medians. SM is nothing but the sum of the medians. Perimeter of a triangle always lies between sum of the medians and 4/3 of the sum of the medians. All these proofs you can easily get in NCERT. In case if you are not convinced, I will tell the proofs in the upcoming classes. Another important point, the sum of the squares of the medians. Squares of the medians is nothing but AD square plus BE square plus CF square divided by AB square plus BC square plus AC square. Sum of the squares of the medians. Sum of the squares of the medians is nothing but 3/4 of the sum of the squares of the sides. Very, very important key points. Very, very important key point. Very, very important key point. Perimeter of a triangle always lies from sum of the medians and 4/3 of sum of the medians. Sum of the squares of the medians is nothing but 3/4 of the sum of the squares of the sides. 3/4 of the sum of the squares of the sides. 3/4 of the sum of the squares of the sides. I hope it is clear. Right, one by one, kindly listen. Whenever we solve a problem, we'll make use of these properties. Again, I'm repeating important point. Median is nothing but the line joining the midpoint of a side to an opposite vertex. Median divides the triangle into two equal areas. Total, there are 6 equal triangles. Smaller is nothing but 1/6 of the total area. Centroid is nothing but the point of intersection of medians. How to find out the length of the median? By using Apollonius theorem. Two important conclusions with respect to Apollonius theorem. Perimeter of a triangle always lies from sum of the medians and 4/3 of sum of the medians, and sum of the squares of the medians. Sum of the squares of the medians. Sum of the squares of the medians. It is nothing but 3/4 of the sum of the squares of the sides. First, centroid. I hope it is clear. Circumcenter. Next comes circumcenter. Next comes circumcenter. To discuss circumcenter, first we should know what is a perpendicular bisector. We should know what is a perpendicular bisector. We should know what is a perpendicular bisector. ABC is a triangle. ABC is a triangle. Take the midpoint D. Drop a perpendicular. Take the midpoint E. Drop a perpendicular. Take the midpoint and drop a perpendicular. I hope it is clear. Perpendicular bisector. Bisects. Bisects means it divides the side into two equal parts. Bisects means it divides the side into two equal parts. Bisects means it divides the side into two equal parts. So here it is nothing but BD is nothing but DC. And if I call it as S, SD is nothing but perpendicular to BC. SD is nothing but perpendicular to BC. Bisects means it divides the side into two equal parts. Perpendicular bisector, that means the line should be perpendicular to a side and it should divide the line into two equal parts. Circumcenter. Circumcenter is nothing but point of intersection. Circumcenter is nothing but point of intersection of perpendicular bisectors. Point of intersection of perpendicular bisectors is called circumcenter. Point of intersection of perpendicular bisectors is called a circumcenter. From this, if I take a center and if I draw a circle, the circle which touch all the sides vertices of a triangle, that circle is called circumcircle. Circumcircle is a circle which touches. Circumcircle is a circle which touches all the vertices of a triangle. Circumcircle is a circle which touches all the vertices of a triangle. A circumcircle is a circle which touches all the vertices of a triangle. There is another circle which touches all the sides of a triangle, that is incircle. Circumcircle is a circle which touches all the sides of a triangle. A circumcircle is a circle which touches all the vertices of a triangle. I hope the idea is clear. What is a perpendicular bisector? What is a circumcenter? And what is a circumcircle? What is a circumcircle? What is a circumcircle? Next key point. Suppose if I take a triangle. If I take a triangle, this is A, this is B, B is C. This is a perpendicular bisector. This is a perpendicular bisector. This is a perpendicular bisector. These are all perpendicular bisector. From center, if I draw a circle, this is nothing but circumcircle. This is nothing but circumcircle. This is nothing but circumcircle. If this is the center, this is nothing but R. Center to any point on the circumference is R. This is nothing but R. This is also nothing but R. If I call this as S, there is one property. Angle formed at the center. Angle formed at the center is twice the angle formed at the circumference. Angle formed at the center is twice the angle formed at the circumference. So angle BSC. Angle BSC is nothing but 2 times angle A. Angle BSC is 2 times angle A. Angle ASC, it is nothing but 2 times angle B. Angle ASB, it is nothing but 2 times angle C. 2 times angle C. I hope it is clear. Angle BSC is twice the angle A. Why it is? Because angle formed at the circle. Why? Because angle formed at the center. Why? Because angle formed at the center is 2 times the angle formed at the circumference. It is 2 times the angle formed at the circumference. It is 2 times the angle formed at the circumference. What is this? Capital R. Capital R is nothing but the circumradius. Capital R is nothing but the circumradius. Capital R is nothing but the circumradius. It is given by ABC by 4 delta. It is given by ABC by 4 delta. Delta is nothing but area of triangle. Delta is nothing but area of triangle. Delta is nothing but area of triangle. Angle formed at the center is twice the angle formed at the circumference. So angle BSC is 2 times angle A. ASC is 2 times angle B. Angle ASB is 2 times angle C. This is the property which I used it. Next key point. Very, very important key point. One is acute angled triangle. Acute angled triangle. If I take an acute angled triangle, these are perpendicular bisectors. These are perpendicular bisectors. These are perpendicular bisectors. If I draw a circle, circumcenter lies inside the triangle. Circumcenter lies inside the triangle. In an acute angled triangle, circumcenter lies inside the triangle. Suppose if I take a right angled triangle, if I take a right angled triangle, if I take a right angled triangle, right angle triangle, one angle is 90 degrees. So if I draw a circle, this is nothing but center. This is nothing but capital R. This is nothing but capital R. This is nothing but capital R. Capital R. Now if you see, this is nothing but the right midpoint, and this is nothing but equal. That means it becomes the median. Very, very point. Capital R is nothing but the length of the median. Capital R is nothing but the length of the median, and it is also half into hypotenuse. It is nothing but half into hypotenuse. In a right angled triangle, very, very important. In a right angled triangle, circumradius is Circumradius is length of the median and it is nothing but half of the hypotenuse. Very, very important point. Very, very important point. Suppose if I take it as A, if it is C, it is B. Total small side will become small c. This is nothing but c by 2. This is nothing but c by 2. R is nothing but c by 2. C is nothing but the hypotenuse. C is nothing but the hypotenuse. Acute angled triangle. Circumcenter lies inside the triangle. Circumcenter lies inside the triangle. In a right angled triangle, it lies exactly at the midpoint of hypotenuse. It lies exactly at the midpoint of hypotenuse. Very, very important point. In a right angled triangle, circumcenter lies exactly at the midpoint of the hypotenuse. Acute angled triangle, it will be inside, and right angled triangle, it lies exactly at the midpoint of hypotenuse. Exactly at the midpoint of hypotenuse. Next one. Next one. Obtuse angled triangle. Obtuse angled triangle. Obtuse angled triangle. Obtuse angled triangle is a triangle where one angle will be greater than 90 degrees. So if I draw a circumcircle, circumcircle is a circle which touches the vertices of a triangle. Circumcenter lies outside the 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 triangle in an obtuse angled triangle. It lies outside the triangle in an obtuse angled triangle. I hope this concept is clear. Again, I will repeat something with respect to circumcenter. To understand what is a circumcenter, we should know what is a perpendicular bisector. To know what is a perpendicular bisector, we should know what is a bisector. Bisector is a line which will A bisector is a point which will divide the line into two equal parts. Perpendicular bisector means the line should be perpendicular and it should divide the side into two equal parts. Like that, there are three sides to three sides. If you drop three perpendiculars, you will get a common point of intersection, which we call it as circumcenter. Circumcenter is a point of intersection of perpendicular bisectors. Through circumcenter, if you draw a circle, you will get a circumcircle. What is a circumcircle? Circumcircle is a circle which touches all the vertices of a triangle. Because it is a circumcircle, it will have circumradius. Circumradius is denoted by capital R, which we call it as circumradius. Generic formula is ABC. ABC by 4 delta. In case if you get confused, if you do not know how it is C by 2, so ABC by 4 delta. ABC by 4 delta. If I take a right angled triangle, with the sides A into A and B, ABC by delta is nothing but half into product of the sides. AB will cancel, which is nothing but C by 2. R is nothing but C by 2. C is nothing but the hypotenuse. I hope the idea is clear. Circumradius is half of the hypotenuse. In center. To know what is an in-center, first we should know what is an angular bisector. Suppose if I take ABC, draw a line. That line will divide the angle into two equal parts, theta and theta. Angular bisector, a line which divides the angle into two equal parts. A line which divides the angle into two equal parts. A line which divides the angle into two equal parts is called angular bisector. Similarly, from B, if I draw a line which will divide the angle into two equal parts, alpha and alpha. Again, I will divide it. B is beta and also it is beta. Angular bisector. Angular bisector. Perpendicular bisector means it should be perpendicular and it divides the line into two equal parts. Angular bisector means it should divide the angle into two equal parts. Next, very important theorem. Very important theorem. Angular bisector theorem. Angular bisector theorem. Angular bisector theorem. What is an angular bisector theorem? If I take ABC, angular bisector is nothing but AD. Listen carefully, sir. This is based upon similarity and congruence of a triangle. From A, what are the sides connecting A? AB by AC is nothing but BD by DC. BD by DC. This is very important angular bisector theorem. Angular bisector theorem. Another thing, sir, can I find the length of the median? Length of the angular bisector. You can find the length of the angular bisector by using AB into AC minus BD into DC is nothing but AD square. This is another very important concept where AD is nothing but the angular bisector length. You can also find the angular bisector length by using angular bisector theorem. Length of the angular bisector is given by the concept AB into AC minus BD into DC is nothing but AD whole square. Perpendicular bisector means it divides the line into two equal parts and it makes an angle 90 degrees. Angular bisector means it divides the angle into two equal parts. Angular bisector theorem. I hope it is clear. Angular bisector. I hope the concept is clear. Next one. Angular bisector theorem. Next one. Another very important concept. Similarly, for a perpendicular bisector, we got a circumcircle. Similarly, if I take an angular bisector, ABC, if it is an angular bisector, D is D. D is nothing but E. D is nothing but F. If I take the angular bisector, from here, if I draw a circle, I will get a circle known as incircle. Incircle is a circle which touches all the sides of a triangle. Incircle is a circle which touches all the sides of a triangle. Incircle is a circle which touches all the sides of a triangle. Incircle is a circle which touches all the sides of a triangle. So in radius is nothing but radius of incircle. In radius is nothing but radius of incircle. In radius is given by delta by S. Delta is nothing but the area of triangle. Delta is nothing but the area of a triangle. S is nothing but semi-perimeter. Delta is R into S. R is nothing but delta by S. Delta is nothing but the area of a triangle and S is nothing but semi-perimeter. Very important. This is for any triangle. Delta is nothing but R into S. R is delta by S. Now see here. Very important key points. First key point. In case of right angled triangle. In case of right angled triangle, in radius is given by semi-perimeter minus hypotenuse. In radius is given by semi-perimeter minus hypotenuse. In case of right angled triangle, in radius is given by semi-perimeter minus hypotenuse. Why it is, that also we will see it. Proof. It's a very, very important concept. Proof. Suppose if I take a right angled triangle, this is A, this is C, and this is B. If I call it as B, opposite to A, let the side value is small a. Opposite to C, let the side value is small c. In case of right angled triangle, in radius is semi-perimeter minus hypotenuse. Now see, this all you can remember only when you solve as many questions as possible. So these are, and it is R. If it is R, total is nothing but A. This is nothing but A minus R. Tangents drawn from an external point are always equal. So these two are equal. A minus R. C minus of A minus R, which is nothing but C minus A plus R. These two are also equal. Tangents drawn from an external point. So these is nothing but C minus of A plus R. So what will be this value? This is nothing but B minus of C minus of A minus R, which is nothing but R. B minus of C minus A plus R, which is nothing but R. B minus C plus A, it is nothing but 2R. R is nothing but B minus C plus A by 2, which again is nothing but, can I write it like this? A plus B plus C by 2 minus C, which is nothing but semi-perimeter minus hypotenuse. In case of right angled triangle, in radius is given by semi-perimeter minus hypotenuse. Very, very important point, sir. In case of right angled triangle, in radius is given by semi-perimeter minus hypotenuse. Semi-perimeter minus hypotenuse. This is the first key point. Second key point. I hope it is clear. Right. Second key point. The distance between in-center and circumcenter. The distance between in-center and circumcenter is given by the distance between in-center and circumcenter is given by d square equivalent to r into r minus 2r. R into r minus 2r. Very, very important point. The distance between in-center and circumcenter. The distance between in-center and circumcenter is given by r into r minus 2r. Any square function value will be greater than or equivalent to 0. So r into r minus 2r is greater than or equivalent to 0. Radius is always greater than or equivalent to 0. R in r minus 2r greater than or equivalent to 0. R is greater than or equivalent to 2r. R by r is greater than or equivalent to 2. Very, very important point. Ratio of circumradius to in radius. Ratio of circumradius to in radius is always greater than or equivalent to 2. Ratio of circumradius to in radius. The ratio of circumradius to in radius is always greater than or equivalent to 2. Third key point. If I take a triangle ABC, if I take an angular bisector, which is nothing but a by 2 and is also a by 2. Angular bisector. This is nothing but BIC. Now see, angle A plus angle B plus angle C, which is nothing but 180. Angle B plus angle C, which is nothing but 180 minus angle A. So if I take this one, this is also an angular bisector. This is also an angular bisector. So B by 2 plus angle BIC plus C by 2, which is nothing but 180. So angle BIC is nothing but 180 minus of B by 2 plus C by 2. B by 2 plus C by 2. So if I divide, angle B by 2 plus angle C by 2 is 90 minus angle A by 2. So if I substitute 180 minus of 90 minus A by 2, what it will become? 90 plus half angle A. Very, very important note. Angle BIC is given by 90 plus half angle A. Angle BIC is given by 90 plus half angle A. Very, very important key points. Extremely important in geometric centers. All these, some of them, generally most of our competitive exam comes under this domain: knowledge, memory, understanding and application. 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 180 minus of 90 minus A by 2, which is nothing but 90 plus half angle A. Very, very important concept. Very, very important concept. Angle BIC is 90 plus half angle A. Angle BIC is 90 plus half angle A. Write down another 3 important concepts. So these ABC, all these I am going to use it, sir. AD is the angular bisector, B is the angular bisector, F is also the angular bisector. Point of intersection of angular bisector is called incenter. What are the important key points? Angle BIC is nothing but 90 plus half angle A. Angle BIC is 90 plus half angle A. AIB is nothing but 90 plus half angle C. AIB is nothing but 90 plus half angle C. AIC is nothing but 90 plus half angle B. 90 plus half angle B. Very, very important key points. Some of them are direct concept based. BIC is 90 plus half angle A. AIB is 90 plus half angle C, and AIC is 90 plus half angle B. 90 plus half angle B. Fourth key point. Fourth key point. Very, very important key point. In an isosceles triangle, all geometric centers, all geometric centers lie on the same line. All geometric centers lie on the same line. In an isosceles triangle, all geometric centers lie on the same line. Lie on the same line. Lie on the same line. Suppose if it is an isosceles triangle, ABC, where AB is equivalent to AC, if I draw a line, in this line only, incenter will be there. In this line only, centroid will be there. In this line only, circumcenter will be there. In this line only, orthocenter will be there. In an isosceles triangle, geometric centers are collinear. In an isosceles triangle, geometric centers are collinear. Collinear means they lie on the same line. All geometric centers are collinear. Only in an isosceles triangle, all the geometric centers lie on the same line. Any 3 points, if they lie on the same line, it is called collinear. In an isosceles triangle, all geometric centers are collinear. All geometric centers are collinear. Fourth key point. Geometric centers are collinear in an isosceles triangle. In an isosceles triangle, all geometric centers are collinear.